All right. So 6.9 set. You're going to have to do some solving. Just as I was explaining in the class, I'm kind of doing this live here to save myself some time. I was explaining to them, this steps up the game just a little bit in that you have to create the diagram and you have to solve. So number 4, Jill put a ladder up against a house to try and reach a light that is out that she needs to be changed. Okay, real quickly, I'm going to draw a house. Maybe I draw the little light right here and it's shining. I don't know, the house, the front door, and the window. There's my house. Okay? She knows that the ladder is 10 feet long and the distance from the base of the house to the bottom of the ladder is 4 feet. Well, again, look at triangle, look at rectangle. We want to label our diagrams what's what. Well, you don't put a ladder up against a house like this. You don't put a ladder up against a house like this. You lean it against the house, right? So the 10 feet is the hypotenuse or the diagonal in the rectangle. That's what the 10 feet is. And then it says the ladder is from the base of the house is 4 feet from the base of the house to the bottom of the ladder. There's your 4 feet. Again, this doesn't look realistic, but it's just a diagram to help you see what is what. Like, what are the sides of the triangle? What are the sides of the rectangle? That's kind of the idea of it. All right. How high does the ladder reach the top of the side of the house? What is the angle of elevation formed by the ladder and the ground? So really what it wants to know, the first thing it wants to know is how high does the ladder reach up the house? Well, this is a right triangle. If you focus solely on the triangle right here, this is a right triangle. You have 4 and 10. How can I find a third side? The third side, or the left side of the triangle, would represent the height of how high the light is above the ground. I know 2 of the 3 sides of a right triangle. How do I find the third? That's a Pythag question. So 10 squared is equal to 4 squared plus b squared. Right there. You can go through and solve that. All right? I'm not going to do it for you, but you can go through and do that. Then the next thing it says, what is the angle of elevation formed by the ladder and the ground? The angle of elevation by the ladder and the ground is over here. I don't need to know how high the house is to be able to solve this first. Why? Because if this is my angle of reference, 4 is a leg adjacent, 10 is a hypotenuse. Cosine is what I'm going to use for there. So the cosine of x is going to be equal to, I'll get rid of my triangle over here that I used, is going to be equal to adjacent, which is 4, over hypotenuse, which is 10. And y'all remember from before that we use inverse. We use an inverse to go ahead and simplify this. So try that one and see. All right? You're going to multiply both sides by cosine inverse and you're going to solve. So do your best with that one. All right? The next one I'm going to look at, and I was kind of debating it here on what to do. It says Francis is flying an airplane at altitude of 3,000 feet. Well, here's my airplane, right? 3,000 feet. G, that's going to be the left side. That's altitude. We have to kind of understand some stuff here, right? It says if the angle of descent in the plane, and I'm going to give you a helpful hint right here. Angle of descent, descent is down. That would be the plane looking at the ground. That's 15 degrees. But wait a second. If I'm going to do this trig stuff, if I'm going to do this, I need to know an angle inside the triangle. Yes, you're right, you do. Remember, the other day when we talked about this, we talked about parallel lines, and this is why this diagram was good. And a transversal, we have alternate interior angles. So now we know that the lower right angle inside the triangle is 15 degrees. Now you can find either the hypotenuse, which the hypotenuse in this case would represent how far the plane would fly. If that's what it's asking, it says, oh yeah, it is. How far will the plane travel through the air before it hits the ground? I want to know how far the plane's going to travel, not how far it is from the airport. How far from the airport would be the base of the triangle or the bottom of the rectangle. How long it's going to fly is the diagonal, because the diagonal is longer, right? It's a hypotenuse, always the longest side. So be careful with that. I'm going to talk about 7, and I'm going to draw the figure and set it up. I'm not going to solve it. You're going to have to do that because we're kind of running out of time here. I got to crunch. A 6-foot tall person is standing 60 feet away from a skyscraper. All right, so I envision this. A 6-foot tall person. Here's my person over here. Okay, he's been out in the sun a lot. He's red today. He's 6 feet tall. Okay, he's looking this way at a skyscraper. Okay? Weird skyscraper, but hey, again, it's just to pretend. Okay? He's 60 feet away. Well, I know that this distance here, or the base of the triangle, or the base of the rectangle, is 60 feet. Now notice how I drew where he's standing. His eyes appear to be on the plane here, and I drew the building down more so. How high is this distance right here? That distance is 6 feet, because that's how tall the person is. Remember, it wants to know how the base. When you look at a building, you don't look down here at the base of it. This would create a triangle like this. That is not a right triangle. I need to do trig. I need to be able to create a right triangle. So you look straight across where that 90-degree angle is. Okay? The angle of elevation for the person's line of sight is 70 degrees. Angles of elevation are up. 70 degrees is the angle inside the triangle. Determine the height of the building. Okay, well the height of the building is going to be my x value. I know leg adjacent, I know opposite, or want to know opposite. So adjacent and opposite is a tangent function. So the tangent of 70 is going to be equal to opposite x over adjacent, which is 60. Now, what do you do with your answer? X is equal to building height plus what? Building height. I have to add the building height to what? How tall is the person? 6 feet. You have to add 6 feet to your answer. Why? Because the person is 6 feet tall. Okay? If you're using any kind of measuring device, that device has to go out, go straight, and form a 90-degree angle. You have to take into consideration and add those extra feet. So use your calculator for that. See what you come up with these. These should be hard. There's only 4 of them to do.